Up, up. There we go. All right. Hello, everybody. My name is McBirney, and I am a manufacturing and project manager at Fictive. My presentation is called Lights Out, the Quiet Revolution of Industrial Automation. My original title was Iron Giants Automation and Manufacturing, because that was what I originally had in mind. But as I did a little bit more research about this topic, I wanted to talk about lights out manufacturing, which is the idea of having an entire factory in which you could technically turn out the lights because it's entirely automated and you don't technically need light to do a lot when all you have are robots, and you save a lot of power by turning off all the lights. So a lot of manufacturing engineers think about lights out automation when they think about what they imagine an ideal factory to be like, which would be pretty much no humans. So that's why it's a quiet revolution, is these robots are coming in, they're automating factories, and what does that mean for us? So a little bit about me. I have 2 bachelor's degrees, one in math from NYU and one in mechanical engineering from the Stevens Institute of Technology in New Jersey. And after I graduated from school, I went and worked at MakerBot. I worked in their factory in Brooklyn as a manufacturing intern, so that was where I got my manufacturing roots, was working in that factory. And that factory was pretty much all manual processes. And so I was helping design assembly lines and work on products where we were really building them by hand and building them with fixtures that we made ourselves, and it was extremely manual. And then after my time at MakerBot, I went and worked for Tesla. And so I was a manufacturing engineer at Tesla for about 2 years, and that was much more automated. We were partially manual, partially automated in terms of processes, and our products were much larger. We were making cars instead of 3D printers, which we were making at MakerBot, and also our production volume was much higher. We were producing a lot more products. And so when you're producing a huge number of products all the time, it's much better to have more automated processes because you're going to be able to make products faster. So as Tesla is ramping towards Model 3 and much higher production and much cheaper vehicles, they need to automate more processes. And so I was involved in a lot of that as a manufacturing engineer at Tesla. And now I work for Fictive. And at Fictive, we do smaller batch production and prototyping, and we connect customers with small contract manufacturers to make sure that they can get their parts made for prototypes and small batch production for CNC machining, 3D printing, and we're expanding into other processes as well in the coming year. So, why automate? Productivity is the main reason that people automate processes. So, you have less human error, which is going to cause you to get more work done in a lower amount of time. Density, you can utilize more space with automation than you can with humans. You can go vertical. You can make extremely tight spaces where you're doing things in an extremely small area, but robots don't really need that much space to move, especially if you're making extremely small products. But being able to expand vertically and expand into 3D spaces that humans couldn't necessarily go into is a huge advantage for productivity. The price of goods is going to decrease as your productivity goes up, and that in turn causes the quantity demanded by the customer to increase, because once they realize that prices are going down, they're going to want more of your product. So in this chart, you can see that this is price indices for consumer electronics for export in the European Union. But you can see that the price of electronic integrated circuits and microassemblies went down a ton between 1992 and 2015. And that's partially due to automation, because they were able to make a lot more products in a shorter amount of time and sell them for less money, and therefore demand went up and they could sell even more products. And then this also generates income for the owners of the financial and intellectual capital of automation. So that's the people who are buying the robots and running the factories. That's people who are designing robots, programming robots, and who are really involved in this automation industry. They're really going to generate a lot of income from this, and in turn put that back into the economy. Another great reason to automate is safety. So after working in a few different factories myself, I can really tell you that it is difficult to make sure that safety is a priority, because you're always balancing speed with safety and quality, and so you want to make sure you're producing a quality product in a very quick amount of time, and you're meeting your sales numbers, but also that all of your humans are safe. So the more humans you use in a process and on an assembly line, the harder it's going to be to keep them safe. So when you automate processes, you have fewer workplace injuries and no ergonomic concerns. Ergonomic concerns are something that people don't really think about a lot with automation, but it's a huge thing, because when you have one person doing one process, a manual process, repetitive many, many times in a row, even if it's something that wouldn't cause them an injury if they did it once or twice, if they're doing it hundreds of times a day, it can cause repetitive stress injuries to humans. And so ergonomic concerns are huge in a factory, and there are whole teams dedicated to that. So not having to worry about that because machines are doing a lot of the heavy lifting. Huh? Yeah, pretty good. And also you can run pretty much 24-hour production because you don't have to worry about labor laws or overworking people or fatigue, and so that's also huge. So that's why a lot of companies are really leaning towards automation, because you're avoiding a lot of these human-related concerns, and it's better for both the companies and the humans, because you really don't want to put humans through these processes and assembly processes and manufacturing things that are really difficult for humans to do over long periods of time and really easy for machines to do hundreds or thousands of times in a row. So, the current capabilities of robotics. Automation provides an advantage in very specific processes for manufacturing, so it's not the best for everything, but for many things it's the best because it's great for things that are repetitive, predictable, and physically demanding. So those types of processes are very easy to automate. So I'm going to show a quick video about a pick-and-place robot, and let's check it out. I don't know if the sound is working. Is sound attached or no? That's okay. Oh, the microphone to the computer? I don't know if the That's okay. I can narrate. So generally, this is a pick-and-place robot, and it's high-speed robotic picking. So it uses a delta format of robot in order to pick and place lots of small parts laterally across a space. So you can see that it can grip small parts in a very repetitive motion, and it uses basic vision sensing in order to grab the parts and put them back on the other conveyor on the other side. So they're sort of discussing some of the benefits of this high quality, consistency, and little human interaction. So one of the main things people focus on in current automation is minimal human interaction, because robots are not good at interacting with humans. Robots work best in automation in factories when they can move really quickly and do processes really quickly. And when you have hard, sharp robots moving really quickly, they can hurt people. And so, especially when they're really big, even with something small like this, you really want to keep humans out of the equation. So there are lots of safety issues involved with using automation in robots. So you want to make sure that the humans sort of stay out of it. There are more automation technologies being developed right now, which allow for more human interaction, which have special sensors that really sense when a human is near, and the human can interact with the robot to have it do different tasks. But it's still sort of in the limited stages in manufacturing, and those robots have to move a lot slower, and they also aren't as precise as robots that you can program to move without human interaction. So that's sort of one of the challenges of current robotics and automation in manufacturing. No, go next. All right, so limitations. As I was saying, it's more difficult to automate tasks that require complex learning. So this is something that's starting to become a thing where robots can learn and apply that knowledge later, but generally right now it's easiest if they just have one task that they do, they sense current information, They use it to their advantage, they do their task, and then they move on. But it's really difficult for them to learn from that. Extreme dexterity, you can see on the bottom left, there's a robot with a gripper on it, and generally grippers are pretty standard and only move in a few different directions. They only have a few different areas of movement, and so it's hard for a robot to grip in non-predictable ways. They can grip one thing at a time or a few things at a time, but it's hard for them to predict like what they're going to grip and then adapt to that. As I said before, it's difficult for robots to interact with humans because they're very fast and they're not good at sensing humans. And so generally, you can see on the right, these are a lot of the safety measures that are involved in an automated assembly line. So there are magnetic locks, there are fencing systems, there are emergency stops, there are vision systems that sense to see if somebody's in the area. And all of these are connected electronically to the robot so that if any safety curtain is broken, any safety scan is broken, the robot will stop. And the system has to be totally reset before it'll start running again. So a lot of these safety measures are made to keep humans from going into the system. It's really meant to have robots running 100% automation all the time. And if humans do have to go in, there are lots of safety measures involved, like this type of safety curtain where the safety curtain can turn off, somebody can go in, do a part of a process, come back out, safety curtain goes back on, and process continues in an automated way. So, areas of advancement for robotics and automation in general. So improvements are going to keep happening in cognition, which is the robot's ability to perceive its environment. So as robots are able to sense better, currently most robots use either a 2D or 3D sensor, so they have a limited view of their environment. But as robots can really learn to see their environment better and perceive that information better, they're going to be able to interact better with humans. Manipulation, precise control, and dexterity. As I said, a lot of ways that robots interact with parts have to be extremely predictable, and they don't do well with improvising. So if you can have a robot that is more able to improvise and able to adapt to its environment a little bit better, advances in manipulation are really going to help automation take over more processes in manufacturing. And interaction, the robot's ability to learn from and collaborate with humans. So really the key to the future of automation is to have all the tasks that can be automated, but for things that can't be fully automated, to have robots be able to work alongside humans in a safe way that makes sure that both humans and robots are working together to get the most productivity out of that process. Because really the reason that we're bringing in automation is to increase productivity. So if we can increase productivity by having humans and robots working together on some things, that's going to be key to the future. So, neural networks, cloud collaboration. I'm going to show another video. And I watched it a few times, so I think I can narrate it a little bit. So this is at a lab in Berkeley, and they have this robot that they taught to use a neural net to pick up objects. So the initial 1.0 version of their software was they gave this robot an area of knowledge that was 10,000 objects. And they used that knowledge of 10,000 objects to scan an object and figure out which points on that object would be the best to pick it up, and then pick it up. So these are the 10,000 objects. But their version 2.0 used a neural net, which basically a robot brain, so that it could learn how to pick up almost any object, not based on 10,000, but based on its brain. I cannot explain neural nets very well. Please do not ask me about them later, but I think that they're very cool. And so it was able to pick up all of these different types of objects. So this is sort of part of the future of automation, is a robot being able to see a pile of things that are totally unpredictable, scan it, figure out how to pick it up, predict it, pick it up, and then if it fails, learn why it failed, and so it can do better next time. So in the future, it'll be able to pick up that object that it failed to pick up the first time. Pretty cool, right? Yeah. So, oh no, that's not what I wanted. Okay, we're good. So, and also cloud collaboration. So something else in this is like having a neural net or having a way for a robot to learn from what it did before is having a lot of robots that are connected via the cloud. And so they all share this area of knowledge within the cloud. And so if you have a group of 20 robots that does the same type of task, and then you need to buy a robot number 21, you can bring in robot number 21. Robot 21 will just dial into that network that all of the other robots are on. It'll know exactly what those robots have already learned. So being able to share that kind of knowledge among robots and share the sensing and computing power among a large group of robots is going to be huge for the future of automation as well. So we're going to go a little less into the tech and a little more into the economics and sociological impacts of automation. So some of the economic impacts of automation are humans losing jobs to automation. This is sort of a given, but it's not necessarily a bad thing. As I said before, a lot of the jobs that robots are going to be taking over are jobs that humans maybe shouldn't be doing anyway, because they're jobs that are repetitive, they're jobs that are boring, or jobs that can injure you. And so if we can automate a process, we probably should. I'll go a little more into that later. And then higher labor productivity. So productivity is how much work you can get done in a certain amount of time, how much work per worker. And productivity is just going to increase with automation, because in tasks that can be automated, the machines are going to be able to do more work than a human could in the same amount of time. And also the investment in the economy grows, leading to short-term GDP growth. So investing in automation is going to help businesses grow and in turn help the economy grow. So the question that everybody's wondering, will robots take my job? So currently, as you can see on the right, 50% of current work activities are technically automatable by adapting currently demonstrated technologies. So this is like technology that already exists but isn't necessarily implemented yet. And 6 of 10 current occupations have more than 30% of activities that are technically automatable. So really, there are a lot of jobs that are just waiting to be automated and just waiting for this technology to be really able to be implemented in these industries. So this sounds a little bit scary, because it's like, oh, work potentially displaced by adoption of automation by 2030 on average is probably about 15%. But it could be anywhere from 0 to 30%, and that's a lot of jobs. That's anywhere from 10 million to 800 million jobs displaced by automation. And so a lot of people are like, wow, I don't want to lose my job to automation. What am I going to do? And a lot of reactions are just, okay, no automation, that's a bad idea. I want to keep my job. But as I said, jobs that are most likely to become automated are repeatable, predictable, physical jobs. So in manufacturing, that can be a lot of jobs. Manufacturing operator, warehouse operator, transport operator, and also jobs that are collecting and processing data. But as I said, those are jobs that humans don't really need to do, and robots can do faster and more efficiently anyway. So the key to automation is job creation. So I wanted to show this chart because it shows how, since 1850, sort of how jobs have changed and how the distribution of jobs over the entire network of jobs has changed. And so the light blue you can see is jobs in agriculture. And in 1850, there were a lot of jobs in agriculture. But in 2015, not a lot of jobs in agriculture. So you can see a huge decrease in percentage points of agriculture jobs by about 55 percentage points. And manufacturing is a little bit different because it started small, got really big, kind of got back to small again. So it's about minus 3 percentage points. But if you look at all of these other industries, a lot of them have grown a lot. So they've taken up a larger percentage of the job force. And so this sort of shows us that jobs in manufacturing will decrease due to automation, but statistically, jobs in other industries will increase, and more jobs will be created in areas where humans actually need to work, and robots can't do the work. So these are jobs like healthcare, people management, and jobs requiring social and emotional skills. So really people-centric jobs are going to become much bigger because robots can't do those jobs yet, and probably won't be able to do those jobs for a long time because the development of AI isn't really going to allow it. So, and creative jobs, because robots tend to do the same thing over and over again, which is not great for being creative. So there's really just going to be a shift into these other types of jobs more so than repetitive physical tasks. So manufacturing has been great for the US for a long time, since the Industrial Revolution, because it provided these jobs where you didn't need a high education and you just needed some training and you could do this job and have good benefits and good pay. But they weren't the best jobs. And so the ideal scenario moving forward is, or one of the challenges is that workers need skills and support to transition to these new jobs and new types of jobs. So that can either be help from the government or help from private businesses, but whoever figures out sooner rather than later how to help these workers transition into non-manufacturing jobs and jobs that will become automated is really going to help our economy, because if we can figure that out sooner, we're not going to see as much of a rise in unemployment due to automation, because the jobs that we need should and will exist, but it's going to be that transition into non-automated jobs that's going to be slightly difficult. And total productivity gains are only going to be achieved if humans can work alongside machines. So we do need to continue to develop automation that can work alongside humans, and because some tasks will only ever be able to be semi-automated and not fully automated. So continuing to develop robots that can work alongside humans and touch humans and do things like that is going to be really important. And then also, in another sense, wealth needs to be redistributed from those directly benefiting from automation. So those people who are buying the robots, people who are designing and programming the robots, we need to come up with some sort of method in order to help distribute that wealth that they're going to gain from that and help workers who are going to lose their jobs. And that's a little bit more complicated in an economic and sociological context, but it's what's exciting about the future of robotics is sort of assisting this change. And people are scared of losing their jobs, but it's also really exciting that we'll be able to put people into jobs that they're more suited to doing, and machines will be able to do the jobs that machines are more suited to doing. And so I'm hoping that people will be happier once they don't have to do those types of jobs anymore. So some conclusions. Robots will take over jobs that humans shouldn't be doing anyway. Repetitive, physically difficult, boring, ergonomically uncomfortable, jobs that can be easily automated. More jobs will be created in industries that require a human touch and require social and emotional skills. And jobs will be created in industries that don't even exist yet. You know, we have a lot of technology that's in progress that hasn't really come into the mainstream yet, and it's hard to predict what kind of jobs are going to be created, but there will be jobs that we, at this point, can't even really conceptualize. So that's sort of another exciting thing to think about. And government assistance is going to be needed to transition these human workers to new jobs that are not in automation. So, yeah, that's it. I have this video called Robots Are Great, but it involves a lot of sound, so I'm not going to play it right now, but I will send it out to everyone, and we'll post the link so that you can watch it later. Thank you.